and welcome to the next problem on the Fall AMC 12b. So we have the largest prime factor of 16,384 is 2, because this is equal to the 14th power. And what is the sum of digits of the greatest prime number that is a divisor of 16,383? So first, we can rewrite 16,383 as 2 to the 14 minus 1 by the given condition. And we see by the difference of squares, difference of squares means that if we have a square minus b square, it can be factorized into a plus b times a minus b. And the proof of this can be using the following method, which you see that a b is cancelled out, leaving us with a square minus b square. So now, with the knowledge of difference of squares, we can factor 2 to the 14 minus 1, which is equal to 2 to the 7 plus 1 times 2 to the 7 minus 1, because we can rewrite this as 2 to the 7 square minus 1 square. Now we know that 2 to the 7th power is essentially equal to 128. Then we can just simplify it to 127 times 129. There's not a trap answer, but 129 is not a It's not a prime number. So we can write as 127 times 43 times 3. Well, is 127 prime? Well, 127 should be prime because you can just test it up to the square root of 127. And then you can see that 127 is divisible by none of 1, 2, 3, 4, 5, 6, 7. No, 2, 3, 5, 7, 9, and 11. Therefore, we can conclude that this is a prime and is greater than 43 and 3. Therefore, our answer is 127, and we're asking for the sum of the digit, which yields an answer of 1 plus 2 plus 7 is equal to 10, giving us answer choice C. Proceeding to problem 7. Problem 7 on the test is actually a big time sink, because it seems like there's not a really effective way and efficient way other than just try the answer choice one by one or try the numbers. And now I want to present a really clever solution, which is, first, you write as x squared minus xy plus y squared minus yz plus z squared minus zx is equal to 1. Now we multiply the entire thing by 2. So now this gives us 2x squared minus 2xy plus 2y squared minus 2yz plus 2z squared minus 2xz. That is equal to 2. Now we don't want to divide by 2 again because this just literally means doing nothing. But we're going to take out 1x squared, 1y squared, and the 2xy, and this gives us x minus y squared. And similarly, we're going to do it with all the x, y, and z, and this gives us x minus y squared plus y minus z squared plus z minus x squared is equal to 2. Since they're all integers, and squares can only be non-negative, then we know that 2 of them must be 1 and the last one be 0. And the only choice that would guarantee 2 of them to be 1 and only 1 of them to be 0 is answer choice D, and thus our answer of the two congruent sides of an obtuse isosceles triangle is equal to the product of base and twice the triangle's height to the base. What's the measure of the vertex angle of this triangle? So keep in mind that the vertex angle is going to be this angle. Now, first let's try to read the problem, and we see that it tells us the product of the base and twice the triangle's height of the base. And what do we first think about? Well, area, right? Because area is equal to base times height divided by 2. Now, keep in mind that this is equal to 2 times base times h is equal to x squared, which x is the congruent size. And also, we know that the area can also be equal to 1/2 times AB times sine C, which C is the angle between them. And we see that since A is equal to B is equal to X, then it's equal to 1/2 times X squared times sine C. So also, left side can be expressed as 4 times the area. It's equal to X squared. So this motivates us to try to get rid of the term area. So we multiply by sine alpha times 1/2, which let alpha be the angle between them, times 1/2, and that is equal to 1/2 times sine alpha. So now, this thing, the right-hand side, is essentially area, right? So this cancels out with this. So we erase both of the sides, and they both become 1, so we just let the right side be 1. So now we have 2 times sine alpha is equal to 1. And then we solve for sine alpha. Sine alpha is equal to 1/2. So now we solve this, and we want to solve for the angle. But keep in mind that this is an obtuse isosceles triangle. Therefore, the vertex angle will be greater than 90 and less than 180 degrees. Therefore, the only angle that satisfies this condition would be alpha equals to 150 degrees, and this gives us answer choice D. So we start with a diagram. 6. And then O is the center of the inscribed circle of this triangle. What is the area of the triangle passing through A, O, and C? So the center is actually known as incenter, which is the intersection point of the 3 angle bisectors of a triangle. And since it's equilateral, then we see that these 3 lengths are actually equal, right? And the center is actually the same as the centroid of the equilateral triangle since it's equilateral. And this doesn't work in other cases. Then by the centroid theorem, this will be in a ratio of 2 to 1. So therefore, since it's in a ratio of 2 to 1, and the height is going to be 3√3. So the height could be 3√3. And let's mark. Then AO is going to be equal to 3√3 times 2/3, which is equal to 2√3. And since it's an equilateral triangle, then it's symmetrical, which means OC is also equal to 2√3. So now we're going to find the area passing through AOC, area of the circle passing through A, O, and C. Then we're basically asked to find the area of the circumcircle of triangle AOC, which the other side is 2√3, 2√3, and 6. Then now we see that if we drop an altitude, then this is 3, this is 3, and this is square root of 3. Therefore, the area, we can use the simplest area formula, which is BH over 2, which is equal to 3 times the square root of 3. Now, what do we do next? The next thing we're going to do is we're going to use the formula of ABC, where 4 times area is equal to R, which R is the circumradius. And this also clearly applies to ABC, or 4R is equal to the area. So we plug in, we see that R is equal to 72 over 4 times 3 root 3, which gives us 2 root 3. So the radius of the circumcircle is 2 times the square root of 3, and now we're basically done. So the area is essentially equal to 2 root 3 times square times pi, which is equal to 12 pi, giving us answer choice B. Now, what is the sum of all possible values of t between 0 degrees and 360 degrees, such that the triangle in the coordinate plane, whose vertices are these, is isosceles? So for here, we know that these all lies on the unit circle. So first, we're going to draw a unit circle to visualize how these points looks like. So point A will be somewhere here, which this is cosine 40 and sine 40, and this will be cosine 60 and sine 60. So a really important for us to memorize here is that the arc length is equal to R times change in theta. So basically, the first one that will result in isosceles triangle would be what? Would clearly be when the third point is in their middle, which is t equals to 50. And also, we can also have one of the side be between these 2 points, between these 2 blue points, and the third point would be first. It'll be 80 degrees, or it can be 20 degrees. And also, don't forget what? We can also have a point over here, which this one is essentially like this angle. So you're going to have 180 plus 50. So this one would give us t equals 230. And since we're asked to find the sum of all possible values, then our answer is therefore 20 plus 50 plus 80 plus 230, giving us 380 as our answer choice E.